Okay, so in the last video, we talked about prompt engineering and the clear framework. In this video, we're going to talk about prompt versus context engineering, what it is, how is it different, and without further ado, let's jump right in. So, what is context engineering? So, context engineering is the practice of feeding your AI agent the right information at the right time. Think of it as building systems that dynamically provide relevant information so your AI can make smart decisions autonomously. The personal assistant analogy is like hiring an assistant and giving them detailed instructions once, like here's how to handle my calendar, emails, and meetings, and then expecting that never to change, but also expecting them to remember everything perfectly forever. Whereas context engineering is like giving your assistant access to your calendar system, email platform, contact database, and filing system. But now, when you say like schedule lunch with Sarah, they can check your calendar, find Sarah's contact information, and see her preferences from past meetings and book accordingly. Right? Can you see the difference? As in, prompt engineering or like the prompts we give it are more like a one off thing, whereas context engineering is it has enough context or understanding based on who the person is, like in this case who the person is, what are our previous interactions. And so, like, even when you're chatting with any of these AIs, you don't know what exactly their context window is, how much of the previous conversation do they actually remember, or how much of the current conversation they actually remember. In ChatGPT, for example, you have the memory, wherein you can say like add this to your memory and it remembers it from a more long term point of view. Because otherwise, like initially when these LLMs came out, um it was very restricted to a single chat, and even within a single chat it wouldn't remember, say, the first message when, say, you are 50 messages in or 100 messages in. So understanding this context, and we look at examples and how this practically works. But basically, context engineering takes into account that the data you're interacting with, the experiences you have, the documents you're working with are going to change with time. So then having like a better way of, say, fetching more recent data, and in this case like the contact information, the relevance or the context that the AI would need to make more informed decisions, is what context engineering is basically all about. So why is it important? Without it, AI agents are like someone who forgets what you just said. They're ineffective and unable to take meaningful action. It's the difference between, like, say, a basic chatbot and an actual AI assistant that can help you out with real tasks. It enables AI to work with your existing systems, whether that's CRMs, databases, documents, rather than just operating in isolation. And it saves money and improves accuracy by giving AI only the relevant information it needs. So this is a slight comparison. So prompt engineering, you can always think of it as crafting a single instruction, whereas context engineering is like a system that you are building for dynamic information access, like something that keeps getting updated with time. So this, as we were looking at in our example, maybe contact information, experiences, or meetups, whether it's emails, like if you're using that data, or in-person meetings and meeting notes. The more of these interactions that you have, and say you are updating them. So think of prompt engineering as, say, crafting a single instruction, versus context engineering, which may be building more of a system for dynamic information access, and one that gets consistently updated over time. Prompt engineering can be thought of as static. You pretty much give it the same prompt every time. Context engineering is more dynamic, it adapts based on the situation. Prompt engineering is kind of like memorizing for a test, whereas context engineering is like having reference materials during the test. Prompt engineering is more of a one time setup. Context engineering is more like an ongoing system that evolves with time. So let's look at a few good versus bad examples. A bad example may be send an email to Captain Holt about the monthly crime statistics. The AI may respond with, I don't have Captain Holt's email or access to the monthly crime statistics. Please provide his email and the report content. The AI has no way to look up contacts or access documents in this case. Whereas a good example with context engineering, for the same prompt, send an email to Captain Holt about the monthly crime statistics. The AI will search the contact database, find Captain Holt's email, access the document system wherein it retrieves the monthly crime statistics, and then it uses the email tool to send a personalized email with the report attached. And then it may respond with email sent to raymond.holt at brooklyn99.com with the monthly crime statistics attached. So again, another bad example is, say the user says, my name is Sarah and I work in marketing. AI responds with, nice to meet you, Sarah. Later in the conversation, if the user asks, what department do I work in? The AI may not have any memory of it. So it may respond with, I don't have information about your department. So there's no short term memory in this case to remember the previous messages in the conversation. A good example with proper memory management, maybe the user says, my name is Sarah and I work in marketing. AI responds with, nice to meet you, Sarah. I'll remember you work in marketing. Later in the conversation, if the user asks, what department do I work in? The AI responds with, you work in the marketing department, Sarah. So a third example is the AI processes, say, an entire 50-page document each time that you need it. So this may be, say, some competitor data or a report that has like 50 pages in it. And basically, it consumes a lot of tokens each time because it has to analyze the entire document. So it costs more and it gives you slower responses. Whereas a good example, maybe you summarize the 50-page document into key points and then it references the full document only when required. So let's look at a step-by-step framework for implementing context engineering. So the first step is you always want to start with the end in mind. So the questions that the user may have or what output they're expecting from the system. So, and then we do what is known as process mapping. So we document all the possible user intents, the way they may interact with our system, and then what the output should kind of look like, and accordingly we would structure our data to meet that output. And so if users ask about performance, always include metrics, time frame comparisons. And so an example of this may be like if we were using an AI to send, say, the monthly crime statistics out, right? We know that we are going to use this AI agent to get contact information, fetch the report or the monthly crime statistics, and then send it out. So if we start with the end in mind that this is going to be what the agent needs to do, we then work backwards and we set up our contact database, or which may be even just a single Google Doc or any doc with all the contact information. We may give it access to a repository like Google Drive where all the crime statistics are saved. And then when we have to send out the email, we would use, say, a Gmail node to actually send it out. We may include an AI node in between to create personalized emails. But basically, once we know what the end goal is, then we work backwards to structure the data and like what we're going to need in the process to give us the ability to give it a single prompt, like send an email out to Captain Holt with the monthly statistics. So that's how we work backwards. And so we implement a tiered memory system, which is basically the first part is the working memory, which is built into the AI platforms or the LLMs you're working with. So this is automatic and you don't need to do anything. But from a short term memory point of view, you can use tools like Redis, which is great for caching. You don't need to know all of these. This is more just like on a side note. So don't get overwhelmed if any of this is too technical. You can use N8N memory nodes or a simple database. And a structure, maybe you may just save a session ID, a messages array, which has, say, the last 10 messages, and give it some context. And then you may also take this a step further and implement long term memory, which is like you may use tools for user data like a CRM, which may be HubSpot or Airtable. You may use a vector database like Superbase or Pinecone, or you may just use a simple Google Sheet or Notion to save data. And so the structure here is that you separate user profiles from the knowledge base. And so, like in our previous example, if we wanted to send an email to Captain Holt, we would get Captain Holt's email from our database and then plug in the email that we were trying to send with the document we needed. So Then we have the internal versus external data strategy. So internal first is faster and cheaper. So this may be user history, company doc, CRM data, and you would use this when you have very user specific questions and company information. Whereas external, you would access say via APIs, HTTP requests. These are usually slower but and more expensive, but you would get access to real time data, industry information, current events. And so based on what your application is and what you are using it for, in some cases you may need internal data, and in some cases you may need external data as well. It's just finding the right balance. And like if you need external data, you need it. So yeah, based on the application you have, you would structure your data in such a way. Again, once you are starting with the end in mind and working backwards, that's when you will figure out what kind of data you need. And we will look at examples throughout all the AI agents we build both in Make and N8N. So accordingly, we will discuss this. This is just, again, like a high level overview for you to understand what these concepts are. You are still like way ahead of anyone who's like even getting into this AI space. Just knowing these concepts and keeping them more at the back of your mind, so that when they do come up in the future, or you read a response from one of the AI models when you are trying to build your application out, they will start to make sense, and then you can dive deeper into them. So basically, don't get overwhelmed. You don't need to know all of this, especially when you're starting out, especially when you're building your first few agents, or even like the more advanced agents. You don't need to know all of this, and this is something you can always learn with time. So don't worry about it. Coming back to point number 4, which is our data freshness guidelines. So we have high frequency, medium frequency, and low frequency. So high frequency are your real time events like say stock prices, weather, and breaking news. You may want to fetch this data on an API call. Medium frequency, which are say daily activities, like say if you wanted to fetch company metrics, user activity, market reports, and you may refresh this by like say scheduling daily updates, which in N8N or Make you can have like a scheduled trigger. And low frequency, which are say weekly or monthly data, company policies, product documents, training materials, and these don't change so often. So for these, you may use something like more long-term storage, like a database, and fetch data from there. And the last one is atomic functionality. So always when you are building, like say your context engineering system out, think of it as an assembly line approach. Like each agent or each part of your workflow or your system should do one thing specifically. So you may have an email agent with only handles email sending. So within that email agent, you may implement the entire clear framework. So you would give it roles, give it examples, show it what good and bad looks like, basically implement the entire clear framework just for an email agent, then do it separately for a data agent, third for a summary agent, and lastly for an agent that coordinates between all of these three specialists and then combines the data or gives you the output you're looking for. Rather than just using one agent to write your email, fetch the data, and generate a summary, like it's far better to have this kind of atomic functionality wherein each agent or each part of the system does only one thing, and it does one thing well. And the benefits are also, when you are debugging, you know say which exact agent or node or part of the system to look at. So if your email is not sounding right, you know it's the email agent. If the data that it's fetched is wrong, it's a fetched the wrong contact information, then you know it's probably something wrong with the data agent. And similarly, if it was with the summary, whereas if you were using one agent for everything, it would be a lot harder to debug, or like just one overarching prompt. And basically, if you are trying to do too much with one agent or one prompt, it's far less likely to give you the desired output that you are looking for. So even from a cost optimization point of view, you can use cheaper models for say some simpler tasks, and you can use more advanced models for say more advanced reasoning tasks. And lastly, for parallel processing, where multiple agents can work simultaneously, and then say they write your email, they fetch your data, they get your summary, and then they give it to the orchestrator agent. Again, this is just for a specific example. Basically, you can have say seemingly independent tasks run in parallel, so that the output that you get is much faster than if they were to run in sequence. You don't have to understand all of these in depth for now. This is more to keep at the back of your mind when we are building some of the automations out, and even when you dive into this for your applications. But again, like I said, keep it at the back of your mind. You don't need to know all of this for now. I hope you learned a lot from this. That's it for this video. I'll see you in the next one. Bye.